Okay, so we're going to talk about parent functions. What parent functions are is the simplest form of a function. Okay. And they're actually, if you look over on the board over there on the wall, there is a poster over here that shows all of the different parent functions. We're only going to talk about 5 of those specific ones, but they're listed here. With these parent functions, we tell what the rule would be. So we tell what family it is, the rule, what the most basic graph looks like, and the domain. And you notice that the domain for all of them except for square root is all real numbers. And the reason it's not for square root is because of why? Why does it say only x is greater than or equal to 0? You can't take the square root of a negative, right? No. Okay? The range, okay? On the range, notice, okay, what's the degree for a linear function? What's the degree? What's the power? 1. Okay? So any of them that have an odd power, the range is going to be all real numbers. Any of them that would have a real or an even power, then there's going to be some restrictions or fractional power. And then it tells where it intersects the y-axis, which we call the y-intercept, right? Okay. Notice that all of them except for the constant function intersects the y-axis at the origin. Okay. So the graph goes through or touches the origin at some point. There's a helpful hint with our graphing. It says make graphs appear accurate on a graphing calculator. Use the standard square window, which a standard window is we get by pressing zoom and number 6, and a square window zoom and number 5. That makes our graphs more accurate. All right, so we're going to take parent functions and we're going to do some transformations of parent functions. So letter A here says to identify the parent function for g from its function rule, then graph g on your calculator and describe what transformation of the parent function it represents. Okay, so hopefully you have your calculator. All right, so first of all, what parent function is this? It says g of x equals x minus 3. Which parent function would that be? Caitlin, which one is that? Which one does it look like here? If I have x minus 3, which one does that look like? Is it constant, which would be just a number? Is it linear, or it just has x to the first power, quadratic x to the second power, cubic x to the third power, or square root? Linear. Okay? It's linear because I look at the power of x, and the power of x is 1, so that means it's going to be a linear function. So this is a linear function. Okay. Now it says, then graph it on your calculator and describe what the transformation represents. Okay, so let's look at the graph on our calculator. We know that the graph of the parent function looks just like this, goes through the origin. So if we look at the graph of x minus 3, it looks like this. So there's the graph of it. What's the transformation that's taken place to go from our parent function, which looks like this, what's the difference? Okay. Matt says it moves to the right 3. Anybody disagree with that? Or think something differently? Goes down 3. All right. So we could, in this situation, we could say that it moves to the right 3 or moves down 3. Now, if I was going to do this one, I would be more apt to describe this as moving down 3 instead of up 3. Okay? And here's the reason why. If we go back and look at what we did yesterday, that when we have shifts that happen, okay, oops, that's reflection. Right. When we talk about vertical or horizontal shifts, and we'll talk about this a little bit more as we go on, that according to this information right here, though, it really it doesn't matter, but when we get more in depth into this, I would say that this is a change vertically, not horizontally, because our point of emphasis in this case is the fact that we're looking at this number right here, okay, that point there. And that point refers to what? Where it intersects the y-axis. And where it intersects the y-axis went from the point 0, 0 to the point 0, negative 3. Okay? And when we get going further with this, we will talk about that a little bit. So as we're going through this, we'll talk about the difference, and actually we'll use the next example to talk about the difference too. All right, so, okay, let's look at letter B then. G of x equals x squared plus 5. Which one's the parent function then, Megan? Like I said, we're looking for the power. Where's the power at? Okay, it's quadratic. Okay, as x squared, so it's quadratic. So this is a quadratic function. And here's how we'll tell the difference then, okay? So graph that on your calculator. Oh, there's the graph of x squared plus 5. The graph of the parent function looks like this. What's the difference? Nathan, what happened? It got wider? I don't think it got any wider. It didn't get smaller either. Okay? Dylan wants to help you out. What did it do, Dylan? It went up 5 places. Okay? So this has been, so this is a vertical shift is what we call it. All right, when we're talking about it moving up or down, it's a vertical shift up 5. Okay? Now, I want you to graph this. Oops, not that. Graph this now, where I put x plus 5 in parentheses and then squared it. Okay, Shelby, what did that one do? Move to the left 5 units. Okay. So that was a horizontal shift. Okay, so here's how you know the difference. Okay, whether it's horizontal or vertical. Okay, if it's on the outside of the function, in other words, if it's added to or subtracted to the parent function. Okay, so that means if I have plus x plus something, or x squared minus something, or x cubed plus or minus something, or the square root of x plus or minus something, okay? Those are all vertical changes, okay? To where if I have parentheses like this, and the exponent is on the outside of the parentheses, then that means it's a horizontal change. Okay? And the horizontal change is always the opposite of the sign you see. Okay? Because those changes are, they're opposite things that happen. So horizontal moves different than what vertical does. Okay? So the one difference is then is that if it's a square root, if it's horizontal then, that would be a shift 5 units to the left. Okay? And that would be a shift up 5 units. Okay? All right. But if it's inside the parentheses, or in this case, under the radical, that means it's horizontal. If it's outside of the radical or outside of the function, added or subtracted to it, then it's a vertical change. Okay? All right? Okay. Number 2 is a cubic function because it's raised to the 3rd power. Okay? And it's a horizontal shift 1 unit to the right. Okay? It says x minus 1, but the minus, when we're talking about horizontal, is the opposite. All right? So 1 unit to the right. Number 3, it's quadratic because it's squared, and the plus 1 is in the parentheses, which means it's horizontal, and this horizontal is going to be to the left. It says plus 1, we move it to the left horizontally. Okay? Number 4 is linear, and that is a vertical reflection. Okay? Not horizontal, it's vertical reflection. Okay? And vertical reflection is across the x-axis. This one you probably could have said either way. Okay, vertical reflection across the x-axis or horizontal across the y-axis. Okay, but I like vertical better. Number 5, it's a square root function. And this has been moved 3 units to the left. Number 6 is a quadratic. And since it's x squared, it's the parent function plus a number, then that means it's a vertical shift up 4 units. Number 7 is linear because it's just x. And then it says minus, so that means it's shifted down square root of 2 units. So shifted down the square root of 2. Okay. All right, now the rest of your assignment you're going to do then for tonight. Okay? You're going to be doing numbers 8 and 9, which on 8 and 9 it says graph the data from the table. And then after you graph it, describe the parent function and the transformation. Okay? So you're going to have to graph it, figure out which parent function that is, which one of those 5 it is, and then try to figure out what the transformation is. Did it go up or down, left or right? Did it stretch it out vertically or compress it vertically or horizontally? Okay? So your assignment is going to be to do 8, 9, and 11 through 15. 8, 9, 11 through 15.